Hello everybody, this is going to be section 2 here on igneous rocks. So we talked a little bit in the last section about this process where you have a lava or a magma and it cools either quickly or slowly and forms an igneous rock. And this process, what happens while it's cooling is crystallization. It is forming crystals out of the different elements which are inside the liquid rock. And depending on how fast it cools, this tells us how big the crystals are going to be. It can either cool very, very quickly, and we can get small crystals, or in some cases, no crystals at all, or it can cool very slowly, in which case we are going to get a lot of time for the crystals to grow and grow and grow and grow and get really, really big. First, we're going to talk about the first kind, so the ones which cool somewhat quickly and which don't have visible mineral grains in them. We have this word here, aphanitic. So it means you cannot see a not visible texture. You can't see the mineral grains in this one. These are typically going to be volcanic rocks. These are extrusive. They exit the earth. They're extruded. They're extant. They're on the outside. They crystallize rapidly on or near the Earth's surface and form very, very small crystals because, well, they tend to cool fairly quickly once they get up here, fairly quickly in geologic terms. And you look at these, if you see a chunk of one of these and you actually look at it, you cannot see the crystals on it without some kind of magnification. These are going to be our extrusive igneous rocks. We've mentioned here some, basalt, andesite, and rhyolite. So that is going to be these fellows here. We have our two end members, the two extremes here. Basalt from the deeper, hotter, darker magmas, the runny ones, and rhyolite from our more felsic, lighter, lots of silica, cooler magmas, which typically form closer to the surface. You can also have phaneritic texture. So these are visible mineral grains inside of them, visible crystals. We call these intrusive rocks or sometimes plutonic. These two are interchangeable. These are going to crystallize very slowly below the Earth's surface. They cool very slowly. There's tons of time for them to grow larger and larger mineral grains. There is also time for the first two numbers in the access code, which are 0, 6. And these are going to form very, very large crystals given how slowly they cool. Large enough crystals that you can see them with the naked eye. That's what distinguishes these. These are going to be gabbros, diorites, and granites. So these down here, gabbro and granite. So these are the intrusive, the slow cooling, big crystal version of these things up here. So this and this are exactly the same thing originally, exactly the same melted rock material. The difference is that this one cools slowly and has big crystals. This one cools quickly and has small crystals in it. And this is another example. Here we have granite and rhyolite. These two things are made out of the exact same stuff. If we were to melt these two, the liquid that they melt into would be exactly the same. The difference is that this one cools slowly, so we get big crystals in it, and this one cools very quickly. And we can also see some other textures for these. It can be glassy texture, so sometimes it cools so quickly, usually it's been exposed to water or something else which helps with this process, that it can't form any crystals at all. It forms like obsidian glass, something which is amorphous. There is no crystals, no internal structure to it at all. It might be vesicular. So you have so much gas which is trapped inside of whatever melt, whatever liquid rock. The gas escapes so quickly, forms tons of bubbles along the surface, and what you see when you actually look at it is that the surface of the rock is covered in holes. This is also associated with quick cooling. There is not a lot of time to form crystals for these. This is something which is at the surface, and the gases expand and move out of the liquid very, very quickly. So if you've heard of pumice, this is an example of a vesicular rock. This is pumice over here. You can see that the surface of it is actually littered with holes. It's very, very difficult to find anywhere on the surface which isn't a cavity. And this is obsidian over here, so completely glassy. There are no crystals inside of this. You can look as hard as you like, you will not see crystals. It is a glassy thing. It is amorphous. There is no orderly internal structure to it. So, chemical composition. Which elements? We divide these into three categories: igneous rocks, or melts, based on silica content first and foremost. So we have felsic rocks. I talk about these being lighter colored, or white rocks, or white magmas and lavas. These are going to have a lot of silicates in them with usually light colored and less dense elements. Silicon, oxygen, aluminum, sodium, and potassium, light in color. You have your intermediates, so these are going to be somewhere in the middle between felsic and mafic. Things which don't have a lot of silica, maybe 40% or so silica as opposed to 70% for felsic. These are going to contain heavier stuff, darker elements. Magnesium, iron, especially, and calcium tend to be dark in color. And we are back to this graph again. So hopefully, now compared to the last lecture, hopefully, you'll know that the next two numbers in the axis code are 0, 4, and you'll be able to fill in a little bit more in terms of your understanding of this. So now we kind of know what basalt, gabbro, andesite, and diorite is. Even if you didn't know what diorite is, maybe this wasn't mentioned, you'll be able to know, okay, well, we have our extrusive andesite, which is intermediate. This is the intrusive equivalent. You have an andesite lava which cools deep within the earth and forms large crystals. Also have on the extreme end here are felsic lavas and magmas, which form rhyolites or granites. Next section is going to be on extrusive hazards.